I'm associate professor in Triple Department of Environmental College. This semester, I'm studying renewable energy system for semester student, and today I'm going to explain about which is coming in 400. So now, give a brief introduction regarding the geothermal. So we all know that geo means earth and thermal means heat. So geothermal means earth's heat. So geothermal energy is the energy which is contained as heat in the earth's interior. And we all know that our earth was a burning planet of billions of years ago, and which is having a core temperature of about 5,000 degrees Celsius. And this is the energy which is going to get extract from the heat stored in the earth, and not only from the heat stored in the earth, some part can be obtained from the solar thermal also, which has been absorbed by the earth's surface. So geothermal energy can also be getting extracted from the solar thermal absorbed by the earth's surface. Then coming to the geological background of the Earth, we all know that the Earth's radius is approximately about 6,370 kilometer, and which can be divided into three different layers like crust, the mantle, and the core. So the crust is the outermost layer, which is about 7 kilometer under ocean and of 20 to 65 kilometer under the continent. And coming to the mantle is the middle layer of about 2,900 kilometer, just lies under the crust, and followed by the core, which is at the center at about 4,000 degrees Celsius and of 3.6 million bars. So this is the diagram which explains the different layers of earth crust followed by the mantle, and then the core itself is having outer core and inner core as two different layers which are maintained at different temperatures and pressures. Then we need to know what are the main components required for constructing a geothermal power plant, so with which we can able to produce the electrical energy without any difficulty. So the main components of geothermal power plant are nothing but the production well, separator, heat exchanger, steam turbine, condenser, generator, and injection well. So let me explain about the function of each and every components in detail. So coming to the production well, this is the first step in constructing a geothermal power plant. So first we need to go with the production well just by digging the earth to a depth of about 3 kilometer to 10 kilometer, and then this process is just similar to that of the production well of an oil rig also. So this production well can be located between 10 to 14 kilometer from the power plant. So in the diagram itself, it is very clear that, and this is the production well, and here we have the power plant is getting located. So suitable location for digging the production well will be around 10 to 20, 14 kilometer from the power plant. And then once the production well has been created, then through that well, we need to place the pipes. And then water or brine is injected through the injection through the production well pipes. Okay. Then separator. So what is the function of a separator is? Separator is meant for removing the non-condensable gases like hydrogen sulfide. So it is not essential that steam will be in the pure form. It may contain some non-condensable gases also like hydrogen sulfide. If the same steam is passed on to the turbine, definitely the turbine blades and the runners will be getting contaminated due to the corrosion process. So in order to overcome this only, we are going for the separator, which is meant for removing the non-condensable gases like hydrogen sulfide. So you have different types of separators like two-phase separator and three-phase separator, which can be applied for the required application. And they can be either constructed in an horizontal manner or in the vertical manner, depending upon the design constraint. And followed by the steam turbine, we all know that turbine is the one which is going to capture the uh, heat energy, that is geothermal heat energy, and then by means of steam it is getting converted into the mechanical energy. So the turbine is the one which converts the steam energy into the mechanical energy. Then the steam can be corrosive due to many non-condensable gases, as I said earlier. So to protect the blades and the nozzles from such corrosive phenomenon, we need to go for the special coatings, and special materials are required for constructing the coatings in order to avoid the corrosive effect of the blades due to the non-condensable gases like hydrogen sulfide. And once if the turbine runs efficiently, then we can come out with the mechanical energy in an efficient manner, which in turn yields the electrical energy. And always we have a condenser unit in all the power plants, the main purpose is to reuse the fuel used. So now here steam is condensed to the vacuum of the turbine exit. After using the steam for running the turbine, at the exit we have the same steam. So that steam will be sent to the condenser unit. So most of the plants use the direct contact condensers that uses the water itself as the cooling media to reuse the same steam for the further cycles. Then next comes the injection well. The excess condensate and the brine from the separator comes back to the underground thermal reservoir. So if we are locating the re-injection wells in appropriate places, the same thing can be used for some more years without any requirement for further addition of units. And let me give a general outline how this geothermal power plants are working. So as initially, as I told you, we need to go with the production well, that is by means of digging into the earth till the geothermal hotspot is found. Then, through these holes, pipes have been inserted, through which the water is sent, and the steam, because of the heat energy inside the earth rock, heat will be extracted, and the water is getting converted into steam, and the steam, in turn, it's getting converted into the mechanical energy with the help of a steam turbine. So here, the conversion process involves two stages. One, first, by means of the Earth's heat, this water is getting converted into steam. That is converting the geothermal energy into the water, and then the steam in turn drives the turbine. So converting the geothermal energy into the mechanical energy is occurring the first step. Then converting the mechanical energy into the electrical energy is occurring in the next step by means of the generator. So here, efficiency of the energy production purely depends upon the temperature of the plant as well as the temperature of the rocks inside the earth. And the water is required to send through the injection well. Once it reaches the rock, then the hot water comes from the production well. This is the cyclic process. And also due to the high pressure, when it reaches the topmost of the earth's surface, it is getting converted into steam. So the separator is the place where the steam that comes from the earth is made clean by removing the brine and the dirt so that they do not damage the turbine blades. So the high pressure and the low pressure steam runs the turbine. So the generator, which is then coupled with the turbine, will act together to produce the electricity. So here comes the condenser, which is nothing but a phase changer, where the steam output of the turbine is given to the condenser, and again it is converted to the hot water. This hot water is then sent to the cooling tower, where it loses its heat, and then sent to the geothermal reservoir for further production of steam. And then the next one is the types of geothermal power plants. So there exist basically three different types, like dry steam power plant, flash steam power plant, and then binary cycle power plant. So coming to the dry steam power plant, here the steam is released from the pressure of a deep reservoir at a temperature of about 180 to 225 degrees Celsius at a pressure of about 4 to 8 megapascal. And here the steam is the only fuel used to drive a turbo generator, and then the same steam is condensed and pumped back into the ground. So at an average of 6.5 kilogram of steam is required to produce 1 kilowatt hour. So this is the diagrammatic representation for the dry steam power plant. From the production well, we can able to extract the steam. That steam is used to run the turbine blades, and at the exit of the turbine, the same steam is obtained and then sent into the condenser, where it has been provided to the injection well for the recycling of steam. And from the turbine, it has been connected to the generating facility, which involves the generator. From there, the power is generated and transmitted to the load center. Then the flash or the steam plants, here the water is pumped at great pressure to the surface. So once if water is pumped to the surface, when the water reaches the surface, the pressure obviously gets reduced. So because of the pressure difference, we can able to get some of the water getting changes to the steam. This creates a blast of steam, and this blast of steam in turn return to the earth, then that should be eaten up by the geothermal rocks again. This is the flow how the flash or the steam power plant will working. So first steam with the water is extracted from the ground, and due to the pressure drop at the surface, we will be getting a flash of steam. Then with the help of the separator, the steam can be getting separated from water. The steam finally drives a turbine. The turbine drives an electrical generator, which is having a capacity to produce about 500 megawatts. And next comes a binary cycle power plant. So this is a power plant where the geothermal water is pumped to the surface and then in turn passed through the heat exchanger, which consists of a special fluid. That fluid is going to boil the water. The heat from the water makes the secondary fluid flash into the vapor, and the newly created vapor spins the turbines. Here we have two tanks. First, as usual, water is converted into steam by means of the heat exchanger. Then it has been sent to the another tank which has a special fluid which is used to boil the water, and the heat from the water makes the secondary fluid flash into vapor. The vapor alone is going to run the turbine. So while the cooled steam is injected back into the earth. So here the temperature, operating temperature is between 100 degrees Celsius and 150 degrees Celsius, and it uses the heat to vaporize the organic liquid. So the examples are isobutane, pentane, etc. The efficiency is about 7 to 12 percentage, and this is the advantage of geothermal energy. So no chance of contamination because there exists no solid discharge, and it contains less harmful greenhouse gases and no nitrogen oxide. Of acid rain is less. Sorry. Then regarding the environmental impacts, risk of water contamination is less, and noise. So I explain you regarding the biomass energy. Thank you all.